Okay, the idea here is I have multiple batteries for this flashlight, and I also have a drill and a reciprocating saw and a skill saw for it. What if I could pull power out of that battery easier for other devices? I've seen adapters that you can buy that have like a USB port that snaps right onto the top of the battery. Then I was looking at the flashlight again. I thought, well, why don't I just mount a port right on the flashlight? I have a round barrel plug jack, I guess is probably the best word, and I just drilled a hole and filed it out and mounted that into the flashlight. I spliced it in above the switch or upline of the switch, so the port is always on, and the batteries are 18 volts. You can't use that directly, in most cases anyway. So one of the things I'm going to be doing with it, I'm going to make a series of adapters and boxes that I can plug into this that will give me USB to charge a phone, and also a adjustable regulated power supply that I can dial it up and down to whatever I need to do. So that's kind of the basis of this project. So I've got these Bosch 18 volt flashlights, and what I thought about was adding a port to the light so I can pull power out of it to run other things. Spin it slow to make sure it doesn't go walking, because that's a round surface. Once it starts to dig in, this flashlight's made out of ABS. Cuts pretty easy. If you run a drill too fast in plastic like ABS, instead of the shavings coming out nice and smooth, they'll tend to weld themselves back together. It'll kind of melt. So that's never good. What I'm going to do to make life a little easier on myself is pull the electrics out of the way. And this is the part that connects to the battery. It just slots right in there, so that'll come out easy. I'm just going to tuck that back so I don't nick the wires when I'm not looking. And then the head comes right off, like so. And the on-off switch comes out. There you go, you got the electrics out of the way. ABS usually cuts pretty easy. Trying to cut towards myself and bleed all over everything. It's looking pretty close already. Would be tempted to use a Dremel on this, but it cuts so fast it would be overkill, and I'll probably end up cutting more than I need to. It's always best to work your way up to the line gradually, and then we'll test fit it. Always best not to open the box upside down. Little X-Acto set I picked up. There we go. A little better control with a different tip. If I'm going to take the time to do something for a hobby, the whole idea of a hobby is that it's supposed to be relaxing and enjoyable. And the more time I waste with crappy tools, it just takes the fun out of it. So if you're going to do it, try to do it right and make it interesting. Yeah, that's the right tool right there. One of the biggest things they taught us in the Navy when I was an aircraft mechanic was find the right tool for the job. Because your odds are it'll be safer, it'll be faster, you won't tear things up as bad. I've got this set of needle files that I use quite a bit now. Okay. That's about bang on right there. We'll slice into the existing wire about halfway up. Chopped a Q-tip in half. Looks about as good as anything. So, tin the leads first on the jack. High precision here, right? Now, think about which way that's going to sit in there. Okay, that should work. Should have worked. Didn't work. Although, I'm trying to get around this thing, but this thing isn't actually used. So what we'll do, take the dikes, just relieve ourselves of that little problem. Not sure, but this should work. This is plastic weld, general purpose plastic solvent cement. It's got MEK, methyl ethyl ketone. So what I'm going to do, paint a little bit along the edge, and then that will kind of wick its way through. And what it does, it basically dissolves on contact the plastic, and then they fuse themselves back together again. What you can do with your strippers is go mid-wire. These are not very expensive. Or you break the wire. You know, that works too sometimes. There we go. If you do it right, it'll push the insulation back enough and you don't break the wire. If you've done this more than once, eventually you will forget to put the heat shrink on. And then you'll see that you have a perfectly soldered joint and no heat shrink. That is so annoying. Just want to make sure the wire is hot and then let the solder flow into it. Shiny is good. If it's dull, it's not good. Okay, big, ugly, nasty looking solder joint. Perfect. I'm looking at it wrong. 0 is off. Pull it down for off, push it up, and then you can see 1. I knew that didn't seem right. That's what's going on. It would not go. Pushing everything down out of the way so when I put it together I don't pinch any wires. Test it with the battery before we put it all back together. Light comes on. So this is going to be hot all the time. Just make sure you don't cross the leads. Good. Yep, just like that. Now I'm going to hot glue that. poured a bunch of hot glue right over that jack. I want it to lock in place, and it'll also keep the wires from touching in case they ever come loose. I'm going on the assumption that hot glue is non-conductive. 18-volt flashlight. There's the power jack that I wired into it. That meter is running directly off the feed, showing 18.2 volts now. The alligator clips run to the leads that come all the way around to here. Totally ghetto. That's an LM317, I think. Something like that. There, now the LED will show up a little better. And that's an adjustable power supply. So I can dial it down to about 5. And it can handle a 30-volt input. And I can go up to 3 volts lower than the input. So I got 18 coming in, so I can go up as high as 15. Okay, so that's that. From here, the idea was that I could use my 18-volt batteries because I've got a bunch of them. I've also got a car charger for them, so I can plug them in. I can charge the 18 volts off of solar, and then use that to run other devices. And you know, the batteries have pretty good capacity. The Blue Core batteries are actually a really good NiCad battery. They have a lot of power. And just to show that it still works, there we go. So I got the flashlight going. Now it's putting 17.8, and that didn't change. So flashlight off, flashlight on, flashlight off. Doesn't move. Not too bad. I bought this set of pin drills, I think is what you call it. It's a little handle here, and it's for doing precision drilling on very small things. And I realized that the collet opened up enough where I could use it with a Dremel tool, and that makes cutting a little detail into plastic really simple, because you can just get really precise grip on what you're doing, and it's, you know, you get in there and just do it by hand instead of turning it too fast. So anywho,